Welcome to this bird's eye view of the Localization Project Management Certification Program offered by the Localization Institute. Let me introduce myself. My name is Willem Stoler. I grew up in Amsterdam, where I obtained my undergraduate and graduate degrees at the University of Amsterdam. After many years in IT consulting and software development, I made the move to localization. I have now over 25 years of experience in all aspects of localization. I became a certified project manager in 2002, and I was very involved with the Project Management Institute as a board member of the Portland and Silicon Valley chapters. Training for localization is a top priority for me with focus on project quality and risk management. I'm a former professor at the Monterey Institute of International Studies, and I'm the creator of the Localization Project Management Certification Program and also a roundtable leader for the Project Management Roundtable. In 2012, the Localization Institute took over the responsibility for localization project management training from Chico University. This resulted in a new localization project management certification program that has been attended by over 600 participants from more than 30 different countries. The program has gone through several major updates and is now offered exclusively online using the Litmus learning management system. The localization supply chain can be very confusing. It's my goal to provide you with knowledge that can be applied directly by you in your own organization.
The LPM certification program is comprised of a blend of self-paced online learning modules followed by a webinar and individual essays. After completion of all online modules and the individual essays, you can attend a 1-hour webinar before taking the certification test. This is an overview of all the modules included in the online training component of the certification program.
Now let's be honest, localization projects do fail sometimes, and therefore I'd like to go over some of the common failure points with you. One of the most important tasks of a localization project manager is setting and managing expectations of stakeholders. Stakeholders are all the people who have an interest or are impacted by the localization of a product or service. Part of the setting of expectations is clearly communicating their requirements, what needs to be localized and when, and with what level of quality. The localization industry is weak in defining explicit quality requirements and the degree of market cultural adaptation, scope. It's essential to document and review localization requirements in detail, including quality scope requirements. If you do not, you will most likely not meet expectations of the requester who asks for the localization or customer who uses the localized product or service. Once you know your requirements, you need to identify workflows and technology used for each content type. This is followed by determining resource requirements and evaluating risks. Skipping any of these steps will most likely result in overruns, delays, and missing expectations of the requester or customer. Planning needs to be done for each project and each transactional localization flow. The amount of planning depends on the complexity of the product or service to localize, the schedule, the budget, the number of stakeholders, and the number of languages. Scope creep is the result of accepting gradual, often small, scope changes without analyzing the impact on the schedule and budget. The impact of scope changes needs to be documented in the form of a change order, such that all stakeholders are aware of the impact on schedule and budget. It's very important to get approval of these scope changes from the right stakeholder, and often the client project manager does not have the authority to approve a major scope change. Some organizations prefer to approve any scope changes before work on those changes is started. This implies stopping localization until the scope change has been approved. Other organizations prefer to start the work on the changes immediately while the change order is being prepared. In transactional localization, workflow changes are always small, but can still accumulate. And in that case, you need to look for trends, an occasional change versus scope changes with each delivery of source content. Risk management is a systematic process of proactively managing uncertainties, constraints, and assumptions in order to increase the likelihood of meeting our project objectives, for example, quality, budget, and schedule. If you simply ignore the risks, your project or transactional workflow will most likely fail. Examples of risk are contractual or requirement risks, for example, incomplete requirements or an unapproved budget, time or cost risks, estimation error, rework, etc., people risks, wrong experience, not enough resources, etc., technology risks, new unproven technology, lack of training with new technology, etc., communication risks, stakeholder expectations not well defined or managed, and external risks, political or natural. Sometimes it seems that in-country reviewers are trying to sink your project. However, understand their expectations, involve them early on in the project, define quality from the start, define clear review processes, and provide easy-to-use tools for the review. The most common schedule changes you get to deal with as a project manager are estimating errors. These can also include omitted activities because you did not include all elements in your work breakdown structure, or maybe you borrowed the work breakdown structure or schedule from a similar previous project. Productivity errors can also occur when some of the content is far more complex or misses context, resulting in a lower productivity for that content. 2. Rework required due to quality issues. 3. Not enough resources available to complete an activity according to the approved schedule. 4. Having to replace resources due to turnover also often has a schedule impact. 5. Any scope changes originating from the client that impact the schedule. Let's talk a little more about estimating errors. In order to do so, I need to take you on a journey in statistics land. In the Develop Budget training module, I mentioned that it's wise to average both productivity and costs instead of relying on the productivity and cost of a set of selected resources. The reason being that due to the delay between planning and implementing, you might not have access to the resources you based your productivity and cost figures on. However, I did not address how to calculate that average, and that is the focus of the next slide. Okay, so you're not fond of statistics, but let me give you some simple examples. 1. 4 people are sitting in a bar all drinking beer. The 4 people all have a net worth of $50,000. But see, Jeff Bezos walks in and joins them. His net worth is $111 billion. The arithmetic mean of the net worth of these 5 people is $22,200,040,000. However, the more realistic median is $50,000. Which number to use to describe the average net worth of these 5 people? As they say in statistics, the arithmetic mean tends to put emphasis on the outliers, while the median ignores the outliers. How is this important to you as project manager when doing productivity and cost estimates? Here are 2 examples. You need to estimate the translation productivity for a new project. You have historical data from 5 translators, 2000, 1900, 1800, 2100, and 5000 words per day. The arithmetic mean is 2560 words per day. The median is 2000 words per day. What would be the most prudent and conservative number in this case? The median, of course. You need to estimate the translation cost for a new project. You have historical data from 5 translators, 0.17, 0.18, 0.20, 0.22, and 0.30 per word. The arithmetic mean is 0.214 words per day. The median is 0.20 per word. What would be the most prudent and conservative number in this case? The arithmetic mean, of course. The most common cost changes you get to deal with as a project manager are 1. Estimating errors. As shown, you could use the arithmetic mean when doing a parametric estimate of the cost. Many other issues are possible. A simple calculation error would result in a cost change. 2. Even if you use the arithmetic mean of a set of historical rates, you might have to use resources that charge a much higher rate due to availability or other reasons. The rate difference might also result from initially not understanding the purpose of the translation. For example, translating a patent where the purpose is to provide information about the patent in a language that the client's scientists can understand could be done by a skilled, experienced translator. However, if the purpose is to file for the same patent in another country, you need to use patent lawyers from that country, which would be much more expensive. 3. Rework required due to quality issues often carries an additional cost. 4. Any scope changes originating from the LSP due to misunderstanding the project objectives would have an impact on the budget. Finally, exchange rate fluctuations can impact the budget or the LSP margin. Let's look at an example. You need to translate 10,000 words from US English into European French. The cost is euro 25 cents per word for a total of 25,000 euros. At the time of the contract, the euro to USD exchange rate is 1 euro equals 1.2 USD. So your cost as a US-based LSP is 25,000 times 1.2, which is equal to 30,000 USD. And the client is paying you in USD. Due to economics change, the exchange rate is changing to 1 euro equals 1.4 USD. So now your cost is 35,000 USD, and you just lost 5,000 USD and reduced your margin accordingly. Therefore, if at all possible, you want the client to pay you in the same currency as you have to use to pay your translators or other external resources.
To further enrich the learning experience, I have included many interviews with leaders in our industry on topics such as neural-machine translation, the dynamic quality framework, geopolitical compliance, advances in internationalization testing, etc. These leaders present companies such as Cisco, Intel, Microsoft, Salesforce, Electronic Arts, Lionbridge, and many others. Let's watch a snippet from an interview on neural machine translation with Jay Marciano.
Why don't you explain a little bit for our audience the differences between statistical MT we all got used about this. Now we basically don't talk anymore about rules-based systems, and then neural MT and what that means as far as usability and applicability.
Sure. So, and I'll stretch it out a little bit longer. So there's been a progression over 70 years in the development of machine translation, from very linguistically simple, even naive systems where you simply did word replacement. You found a word in one language and you just dropped in what you thought was the best translation for that word, but with no variation. It didn't depend where the word appeared in the sentence. Nothing of the sort. No grammatical sophistication to it at all.
Cookie-cutter approach.
Exactly. And from there we advanced to rules-based, as you said, rules-based MT systems, where the attempt was to describe language to the computer. So to explicitly write programs that would do a grammatical parse of the source sentence, and then have rules that would try to take that structure and transfer it into the target language. And they were run, so you had rules and you had dictionaries that supported that process. In the early 1990s, IBM came up with the idea of statistical machine translation. It's interesting to note that it was 1991 that the paper came out, because they had to wait almost 10 years for computers to be powerful enough so they could really try out these ideas at scale. And one thing we see in machine translation again and again is that the computers advanced in their power, and then we were able to try more and different things. And so statistical machine translation came, not surprisingly, after translation memory began to be a thing in the early 1990s.
Sure, because I worked with the early systems, that is well even DOS-based systems.
Yeah, and exactly. And so what translation memories allowed us to do is to start collecting data, start to collect source sentences and the corresponding translations for all kinds of things that were translated. And you remember it was a radical thing at the time to save translations, but now it's absolutely standard process. So what that allows you to do is to collect a great deal of information that has been translated, source sentences translated into multiple target languages. And with that, you can start doing machine learning. And machine learning is simply where, as opposed to rules-based system, where I'm trying to describe language to the computer, you say to the computer, here's some language, look at it and learn from it.
So it's learning by example in many ways.
It's learning by example. It's not the same as example-based MT, which is something else, right?
Yeah.
And so with statistical MT, what we did was apply methodologies that came from speech recognition systems, called a hidden Markov model, doesn't matter at all, but it's where you take little bits of the source sentence and you correlate those to little bits of the target sentence, and then you create a statistical model of how those two languages relate to each other, but even more so how the little bits of those language relate to each other. And the funny thing with statistical is how well it worked. And I use past tense. There are still many people using statistical MT systems because it doesn't even look at the entire source sentence. No. It never does. It breaks it down into these little bits and then it stitches things together in the end to come up with a translation. But it's based, I like to compare it to a chess program. A chess program calculates all of the possible moves and then selects the one best move.
Right.
And a statistical MT system creates many, many, many candidate sentences and then looks at which one of those sentences looks the most like the target language should look. And by that I mean which of those sentences has an order of words that is most likely to occur in the target language. An example in English is that the word the is almost never, ever, ever followed by the word the. And so that would be a case of something that if you saw that, you would say, that's not a good translation, that's not a good string of words in English, throw it out. However, the plus big might appear a great many times, so that would be a more common thing to occur. And so if you had one candidate sentence that had things that were not likely to occur together, you would throw that out in favor of one that had something
interesting. That reminds me a little of cryptology, where you also look at frequencies of combinations.
Well, all of machine translation, in effect, came out of cryptology, came out of an experiment that here's a text that I don't understand, put it in a form that I do understand it in. And as a matter of fact, Alan Turing, who the father of the digital computer, who was on the team that cracked the Enigma code in World War II, and as I said, is the father of the digital computer. In a paper that he wrote, I believe, in 1950, said that with these things that didn't exist yet, digital computers, computer scientists should look at 5 things, and one of them was translation. So even the father of the digital computer said that translation was something to do. So after statistical MT, whose heyday was from 2000 to about 2015, we started using deep learning and neural networks. And deep learning is simply machine learning that results in a deep neural network. And a neural network is simply a series of decisions that get made. And when there are multiple layers of decisions that get made, it's considered deep because you have all those different layers. So the only difference between machine learning and deep learning is the depth of the thing that you're creating. But the more important thing with neural MT, and the way it really differs from statistical, is that in statistical MT, you gave the computer these translation memories to learn from, and you told it exactly how it should learn. You said, break up the source into little bits, break the target up into little bits, and correlate the two with each other. With neural MT, you just give it the data, and you say nothing else. You say, here's the data, learn about it. And so the thing that's really crazy about neural machine translation is that even the people who originally programmed it don't really know how it works. And by that I mean is that any one of those decision points, any one of those neurons, those little, where some little thing gets decided, we don't know and have no real way of knowing exactly what's being decided in there. It's a little bit scary for somebody like me who spent 10 years working on a rules-based system where it was very explicitly stated what we are trying to do, and you could go in and you could debug it. You could see what went wrong. With a neural system, all you can do is say, okay, I see that the output doesn't have the quality that I need, so I need to increase the amount of training material or improve the training material that I'm using. Or in theory, you can try to improve the learning algorithms, but that takes a real specialist in machine learning to do that.
Thank you for watching this overview of the Localization Project Management Certification Program. You can register for this program on the Localization Institute website.